Good morning. Welcome back to our course on the C programming language. In this session, I am going to discuss a topic on the Towers of Hanoi. What actually is this Towers of Hanoi problem and why we are going to discuss this Towers of Hanoi problem? All these things we are going to discuss in today's session. So, the Towers of Hanoi has other names, like it is also called as the problem of Benares temple. So, initially we will go with the history or something related to that, the myths what are there in this Towers of Hanoi, all these things we will discuss, right. And then we will move into the actual topic. It is a very simple topic, but the concept you need to understand it, right. So, the other name for this Towers of Hanoi is the problem of Benares temple, and it is also called as Tower of Brahma. And sometimes we will also call it as Lucas Tower. I will tell you the reason why it is called as the problem of Benares temple and Tower of Brahma and Lucas Tower, right. I am not going into this what this Towers of Hanoi is, what is the problem we need to define and what is the objective, all these things I am not going to define. But basically I told that we will be discussing about, initially we will be discussing about the myths that exists with this Towers of Hanoi problem, right. So, the first myth what we have for this Towers of Hanoi is, we know that in Benares it is a famous and the oldest ancient town in India. Which we also call it as Kasi, and we have a deity there who is called as Kashi Vishwanath temple. So, there is a myth saying that in Benares and inside this Kashi Vishwanath temple there is a room, and within that room we have 3 towers. And there are 64 golden discs, and all these discs are of different sizes in the sense they have different diameters. So, in that particular room we have 3 towers. Of course, they are time worn in the sense they are disturbed because of long age it is having, right. And there are 64 golden discs, and there exists priests within the temple, and the role of these priests in the temple is to move these golden discs from one tower to another tower. And when the priests move these 64 golden discs from the source tower to the destination tower, the myth is that that will be the end of the world. And the priests will be moving these 64 golden discs from one tower to another tower with some specified rules, and these rules are governed by Brahma. So, by following the rules that are given by Brahma, the priest will be moving all these 64 golden discs from one disc to another disc with these rules, right. And once the priest completes all the 64 golden discs to be moved from the source disc to the destination disc, they treat it as the end of the world. And when we, because of this reason, because of this Benares. So, all these myths they treat that they happened in Benares. So, it is also called as problem of Benares temple, and I told that the moving of discs from one tower to another tower is governed by the rules that are kept by Brahma. So, it is also called as Tower of Brahma. And why it is called as Lucas Tower, I will discuss it with a short while. But before that, the myth is that when the priests complete these 64 discs to be moving from the source this tower to the destination tower, it will be the end of the world. But when it will happen, right? So, we have a formula for this, that if we have 64 discs, to move all these 64 discs from the source to the destination, we require 2 power 64 minus 1 steps. If you consider moving of one disc from one tower to another tower as one step, and if you consider that moving of one disc from one tower to another tower takes 1 second, it will take 2 power 64 minus 1. So, we have total number of steps as 2 power 64 minus 1, and if you assume one step takes 1 second, 2 power 64 minus 1 steps takes 2 power 64 minus 1 seconds. This is almost equal to some billions of years, almost equal to some 500 billion of years. The priests, when they start and they transfer all these 64 golden discs from the source tower to destination tower, it takes 500 billion years, and this will be the end of the world. So, this is the myth we have that rotates around this Towers of Hanoi problem. But why it is called as Hanoi? As I told that, I am explaining about the myths around this Towers of Hanoi, and the Towers of Hanoi is having other names like problem of Benares temple and Tower of Brahma. So, all these myths what I have discussed till now will revolve around these problems, that is problem of Benares temple and Tower of Brahma. And coming to our actual problem, what is this Towers of Hanoi, right? This is the first myth what we have, but coming to this Towers of Hanoi, there exists another myth, the same myth which they are not explaining in terms of Benares temple and Kashi Vishwanatha, right? So, they are explaining it in terms of Hanoi. So, Hanoi is a place which is a capital city of Vietnam. There they have a temple, and within the temple, instead of priests, have monks, and the monks they keep on moving the discs from one tower to another tower. Instead of priests, the monks will be taking the role, right? The same myth, when the monks complete their task of moving all these discs from one tower to another tower, that will be another that will be the end of the world, right? But what they have considered is it requires 2 power 64 minus 1 steps only. But what their myth says is, for completing one step they take 1 day. So, for completing this 2 power 64 minus 1 steps, they require those many days, which is still a longer thing, right? Rather than this 1 second, we are considering it as 1 day. So, this is all the myths that revolve around this Towers of Hanoi problem. But when we come into the actual mathematical era, and when I want to explain this Towers of Hanoi with respect to the mathematical problem, so this is a mathematical puzzle. This is a mathematical puzzle we have, and this was proposed by Edward Lucas in the year 1883. Since this mathematical puzzle was proposed by Edward Lucas, it is also called as Lucas Tower. So, I have given the reasons for these different names like problem of Benares temple, Tower of Brahma, Lucas Tower, right. And with these introductory concepts of these Towers of Hanoi and different myths we have around these Towers of Hanoi, let us discuss what this Towers of Hanoi is. So, as I told that this is a mathematical puzzle which was invented by the famous French mathematician Edward Lucas in the year 1883. So, the game starts with 3 pegs, we call them as peg. Peg is nothing but a tower. We have 3 pegs and we have n number of discs. This n can be 1, 2, 3, 4 and so on up to any number. So, n number of discs will be there, and as I told that these discs are of varying size, that means they have different diameters like this one. This is disc 1, this is disc 2, this is disc 3 and this is disc 4. We call the first peg or the first tower as the source tower, which is indicated by a letter S. And there exist other 2 towers which are indicated as A and D. So, S stands for source and A stands for auxiliary and D stands for destination. The objective of this mathematical puzzle is whatever discs you have, how many number of discs, it is irrespective of the number of discs. Our objective is to move all the discs from the source peg to the destination peg D by making use of the auxiliary peg. That is our objective. It looks very simple, right. So, when you want to move these 4 discs D1, D2, D3 and D4 from the source peg to the destination peg, you may be thinking that you just pull this D4 and place it in the destination, pull this D3 and place it over D3. This is not the actual puzzle. Moving the discs from the source peg to the destination peg is nothing, but you have to move the discs from the source peg to the destination peg with the help of some rules. We told in the previous slide that these are the rules defined by Brahma, right. So, the objective of this Towers of Hanoi is to transfer the entire number of discs, that is the tower, to one of the other pegs with legal moves. What are these legal moves? Means nothing but these are the rules you need to follow while you move the disc from one peg to another peg. So, a legal move is, the first rule is you can move only a disc at the top of the tower. So, you cannot take 2 discs at a time, or you cannot take the middle disc like this. You cannot take this disc, you cannot take this one. You have to move, whenever you want to move a disc, you have to take the top disc only. That is the first rule. And the second rule is you can move only 1 disc at a time. So, you cannot take these 2 discs and put it in destination peg or in the other peg, or you cannot take all the 4 discs and place it in the destination peg. So, there is no puzzle at all if that is the case. So, the second rule is you can move only 1 disc at a time, you can hold only 1 disc. And the third rule, very important rule, is you cannot place a larger disc on the smaller one. You always have to place the smaller disc over the larger one. So, when you place the larger disc over smaller one, assume that the smaller disc will break. So, these are the 3 rules we need to follow, and we have to move all the discs from the source peg to the destination peg. The rules are you can move only the top disc, you can move only 1 disc at a time, and you cannot place a disc, a larger disc on top of a smaller disc. By making use of these 3 rules, you have to transfer all the discs from source to destination, right. This is what a Towers of Hanoi is. We have discussed what this Towers of Hanoi is. Now it is time to discuss why we are discussing this Towers of Hanoi. The reason why we are discussing this Towers of Hanoi is, this is a very good starting example to explain the concept of the advantages what we get from the concept of recursion. In the previous sessions, we have discussed the concept of recursion, where a function calls itself to get a solution for a particular problem. A function calling itself, the method where a function calls itself is called as recursion. In order to explain the concept of recursion clearly, or in order to explain what advantage we get from these recursions, we will be explaining the concept of Towers of Hanoi. That means, the Towers of Hanoi problem can be solved iteratively as well as recursively. But when you solve this Towers of Hanoi iteratively, the time complexity will be very high, and when you implement the solution for this Towers of Hanoi by making use of recursion, you will get a very efficient algorithm. So, in order to explain the advantage of recursion over iteration, it is a general practice that we explain the concept of Towers of Hanoi. So, that is the reason why we are discussing this Towers of Hanoi concept. Right. So, let me take an example. So, let me take an example where I am taking the value of n is equal to 1. That means, the number of disks what I have is only 1. So, this is my source peg, this is my auxiliary peg, and this is my destination peg. This is source, auxiliary, and destination. Assume that I have a disk on the source peg. The objective is to move the tower from the source to the destination with that rules what I have mentioned, the 3 rules what I have mentioned there. Since you have only one disk, it is a direct solution that you move this disk 1 from the source to the destination directly like this. So, the number of steps, that means only one step is required. Step 1 is move disk 1 from source to destination. So, within this single step you are going to complete this Towers of Hanoi problem, that too with n is equal to 1. So, only one step is required. Let us see, let me increase the number to 2, let n is equal to 2. I am drawing this same thing. I have 2 disks, one is larger disk and another one is smaller disk. So, this is D1 and this is D2. For this particular problem where n is equal to 2, when you want to move this entire tower from source to destination, you can make use of this auxiliary peg. So, the first step what you have to do is, you cannot move D2 from source to destination. Why? Because the second step will be you have to move D1 from source to destination, but according to the third rule you cannot place a larger disk on the smaller disk. So, what I will do is, in step 1 I am moving disk 2 from source to auxiliary. So, move disk 2 from source to auxiliary. So, I have removed this one and I have disk 2 here. Now, step 2 is move disk 1 from source to destination. Move D1 from source to destination. Now, I have removed this one also. So, I have disk 1 here. Now, the last step, simple step, you have to move disk 2 from auxiliary to destination. So, move disk 2 from A to D. So, when you move the last disk, I will be getting like this. So, I have achieved my objective of transferring the entire tower from the source to the destination. Of course, we have used the auxiliary peg. That is the purpose of the auxiliary peg. You need to make use of the auxiliary peg to move the entire tower from source to destination. So, when n is equal to 2, I am going to complete the task in just 3 steps. And when n is equal to 1, I am completing the entire task in just 1 step. Right. Now, let me increase one more disk, n is equal to 3. So, I have the source peg, I have the auxiliary peg, I have the destination peg. 3 disks like this, and let me take the disks as 1, 2 and 3. The objective is to move the entire tower from source to destination with the legal moves. The legal moves are 3 steps. You can move only one disk at a time. You can remove only the top disk and you cannot place a larger disk onto the smaller disk. So, let me complete the task. What is the step 1? I have to move disk 1, this one, from source to destination. So, this is removed and I have placed here. This is disk 1. And step 2 is move disk 2 from source to auxiliary. Move D2 from S to A. And step 3, you cannot place disk 3 on disk 2 or disk 1. Therefore, you have to move this disk 1 to auxiliary. So, you have to move disk 1 from destination to auxiliary. So, I have completed 3 steps. Now, I have 2 things here like this, and now I move this last disk, that is disk 3, from source to destination. So, move disk 3 from source to destination. So, I have the larger disk placed over here like this. This is D3. And coming to step 5, now you have to move this tower which consists of 2 disks to the destination like this. So, you have to follow the same rule. You can make use of this. Now, I do not have this any disks on this tower, right. This is the final position I have. This is D2 and this is D1, this is D3. Now, I have to move this entire tower D1 and D2 to the destination by making use of S as auxiliary. So, initially I move D1 from auxiliary to source. So, move D1 from A to S, and then at this position I have D1 here, D1, D2 is here and D3 will be here. Now, I move D2 from A to D, auxiliary to D. So, I have D2 here like this. Now, this is empty. Now, the last step, simple step, is move D1 from source to destination. So, this will be empty and this is B1. So, the objective of moving 3 disks from the source to destination by making use of auxiliary has been completed in 7 different steps. So, if you have n number of disks which is equal to 4, you will be completing the entire task. You can practice it in 15 steps. Like this, if you go on calculating it, the generalized formula for the number of steps that are required to move n number of disks from source to destination will be 2 power n minus 1. So, for one disk n is equal to 1, we have 2 power 1 minus 1, that is 2 minus 1, that is only 1 step is required. And for n is equal to 2, I have 2 power 4 minus 1, that is 3 steps. And for n is equal to 3, it is 2 cube minus 1, that is 8 minus 1, it is completed in 7 steps. So, if you go to the Brahma tower, I have 64 disks and the number of steps that are required to transfer the entire tower from the source to destination will be 2 power 64 minus 1. This is the reason why we have told that one, right. So, if one step takes 1 second, 2 power 64 minus 1 steps requires 2 power 64 minus 1 seconds, which is equal to some around 500 billion years. This is what we have justified from the first discussion, right. So, this is the way how we are going to transfer the entire tower from the source to the destination with the legal moves. But the reason why we are discussing this Towers of Hanoi is, I told that we are going to discuss this to get an idea of what advantages we will get from the recursion, right. So, there is a recursive solution for the Towers of Hanoi, which is a very simple solution. So, it consists of only 3 steps. As I told that we call these 3 pegs as source, auxiliary and destination. I named it as S, A and D, nothing more than that. The solution is, I know how to move one disk from the source to the destination. It is a very simple task, direct task, where I have explained here, this one. You move that single disk from the source to the destination directly, right. But before that, what I have to do? I have to move the top n minus 1 disks. So, assume that I have n disks. I have the solution for 1 disk, and if you find the solution for n minus 1 disks, then it will be very easy to find the solution for the entire Towers of Hanoi problem with the help of recursion. So, the first step is you have to move the top n minus 1 disks from source to auxiliary. This is what we have done in this one. So, at one point the entire tower, the top n minus 1, that means D2 and D1, 2 disks has been moved to the auxiliary peg. So, that is the first step. So, the first step is you have to move the top n minus 1 disk from source to auxiliary tower. Now, we are left with only one disk, that is the nth disk on the source peg. So, you just transfer that nth disk from source to destination. This is step 2. And the last step what we have is, whatever n minus 1 disks we have on the auxiliary tower, they will be transferred to the destination tower. We already have the solution for the n minus 1 disks moving from one peg to another peg. So, we apply the same solution to this one also. So, this is a recursive call, this is a recursive call. So, you can make use of the recursion to solve this particular Towers of Hanoi problem, where you will be completing the entire Towers of Hanoi problem with just 3 steps. The 3 steps are very important. You have to first move the top n minus 1 disk from source to auxiliary, and then you will be left with only one disk on the source. You just move it from source to destination, and since you already have the solution for the n minus 1 disk moves, now your task is, the step 3 is move that n minus 1 disks from the auxiliary peg to the destination peg. That is it. This one. So, this puzzle is well known to the students of computer science because it appears in every introductory text on data structures and algorithms. So, we will start the concept of data structures by discussing the concept of recursion, and while you discuss the concept of recursion, you will be discussing the Towers of Hanoi, right. So, here you can see the solution here. The solve is the name of the function, it accepts 4 parameters, n represents the number of disks, and source SRC represents the name of the source tower, AUX represents the name of the auxiliary, PEG and DST represents the name of the destination. So, if n is equal to 0, if there are no disks on the source PEG, then you have to exit it, you come out of it, you come out of the program. So, at least one source, one disk should be there to implement this solution. If n is greater than 0, else means if n is greater than 0, you are calling the same function solve, but the step 1 is you have to move the top n minus 1 disks from source to auxiliary. So, it accepts the first parameter as n minus 1, this is the number of disks, this is the source PEG, and you are going to transfer the n minus 1 disks from source to auxiliary by making use of destination as the auxiliary PEG. And step 2, it is a very straightforward one, you move the nth disk from source to destination, and this is step 3, where you are going to transfer those n minus 1 disks from the auxiliary PEG to the destination by making use of source as the auxiliary. So, you are calling this solve function 2 times in the same program. So, a function solve is calling itself 2 times. So, this is an example of binary recursion. So, this is an example of recursion where a function is calling itself. So, you are going to solve any number of, you are going to solve the Towers of Hanoi for any number of disks by this simple Towers of Hanoi solution, by this simple recursive solution. So, that is the power of the recursion what we have. So, the large problem has been completed with a simple task. So, the same thing what we have discussed in the earlier session, if the number of disks is 1, number of moves will be 1, if it is 2, it is 3, if the number of disks is 3, 7 steps are required, if the number of disks are 4, 15 steps are required, if the number of disks are 5, 13 steps are required. So, the generalized formula will be 2 power n minus 1, where n represents the number of disks, right. That completes the entire discussion on the Towers of Hanoi. Let me have a quick recap of what we have discussed in today's session. We started our discussion on the Towers of Hanoi with the various names that exist for this Towers of Hanoi, like the problem of Benares temple, the Tower of Brahma and the Lucas tower. We have explained the myths that revolve around this Towers of Hanoi problem and why it is called with different names, like the problem of Benares temple and the Towers of Brahma, and then why it is called as Lucas tower means it is given it was given the name after this founder French mathematician, which is called as Edward Lucas, who is called as Edward Lucas. But basically this Towers of Hanoi, forget about those myths, this Towers of Hanoi is treated as a mathematical puzzle where there exists 3 different pegs, that is towers, and there exists n number of disks of varying diameters, and initially every disk will be placed on the source tower with the smaller disks placed on the larger disk. And the objective of the entire Towers of Hanoi is to move the entire tower from the source to the destination with the legal moves. The legal moves are 3 steps. The first one is you can move only the disk which is on the top of the tower, and the second rule is you can move only one disk at a time. The third rule is you cannot place a larger disk on the smaller disk. So, with these 3 rules you have to transfer the entire tower from source to destination. Objective. We have seen some examples where we have transferred one disk, where I have used n is equal to 2, and I have discussed the various steps that are involved for moving 3 disks from source to destination. Like this is a solution for 3 pegs. We have 3 pegs with 4 disks, right? And this is the recursive solution what we have explained. The first step is move the top n minus 1 disks from the source to auxiliary, and then second step is you move the nth disk from source to destination, and the third step is you have to move the top n minus 1 disks from the auxiliary to destination. So, this is the recursive solution what we have explained, and this is the generalized formula for getting the number of moves with when we have the number of disks. That's all for today's session. Thank you one and all for joining the session.